Hello, welcome to this channel. Now we'll see a mathematical concept on limit. Evaluate the following limit, that is limit x tends to 0 root of x plus 4 minus 2 by x. We'll see how to do this problem of evaluating the limit. This is the given question. Limit x tends to 0 root of x plus 4 minus 2 by x. Suppose if you directly substitute x is 0 here, see x is in the denominator. If you put x is equal to 0, the denominator becomes 0. Also in numerator, if you put x is equal to 0, this is root of 4 minus 2. So numerator also becomes 0. So this will assume the form 0 by 0, which is indeterminate. Therefore, to evaluate a limit, we will follow a method. There are several methods. We follow this method. What do you do? Multiply numerator and denominator by root of x plus 4 plus 2. Root of x plus 4 plus 2 divide by root of x plus 4 plus 2. This is the given function. What is the advantage of this? See, this is a minus b, this is a plus b form. So a minus b into a plus b. A square minus b square will come in the numerator. See here, limit x tends to 0, a square root of x plus 4 the whole square, which is x plus 4, minus b square, which is 4. Right? The denominator, of course, you have x into root of x plus 4 plus 2. This minus 4, this minus 4, this plus 4 will give you 0. X and x will get cancelled. So next step would be limit x tends to 0. This x is there, this x is there, as you can see. Plus 4 minus 4 add up to 0. Is it clear? Of course, you can cancel out this x with this x. And you are left with limit x tends to 0, 1 by root x plus 4 plus 2. Now you substitute x is equal to 0. That is 1 by x is equal to 0 means this is 2. 1 by 2 plus 2, 1 by 4. So the value of the limit x tends to 0 root x plus 4 minus 2 by x is half. Okay. Now let's analyze this function. We will take up this function and analyze the function. Right. Let's find the domain of the function. So when we think about the domain, one thing is sure. X should not be 0, one thing, and also x should not be less than minus 4. Because if it is less than minus 4, you will have a square root of a negative number. Right. Therefore, should be the domain in domain of x should not be 0, it should not be less than minus 4. So you give it in mathematical form. See here, x can be minus 4, but x should be greater than minus 4. And it should be less than 0, because x 0 should be avoided. X can be greater than 0 also. This is a domain of the function. Now when you draw the graph of the function, you will have the graph. Now you can see this domain part. So here the domain, that is x should be greater than minus 4 or equal to this much portion for the domain, and should be less than 0. See, there is an empty circle here. Or x can be greater than 0, this side. This is a domain part of, this is a domain of the given function. Right. Now we will go to the range of the function. Range means what? All the y values. Right. Now you consider this as the range of the function. You see here the range of the function this side, when you concentrate, it should be less than 1 by 4. The y value you should consider. So f of x should be less than 1 by 4, not equal to 1 by 4. And then it can go here. You see it to a very long way it goes. It may approach the value of y may approach 0, right? So we can say that f of x is greater than 0, this much portion. Coming to the range on this side, f of x should be greater than 1 by 4. You just see, sorry, f of x should be greater than 1 by 4. You see, go this side. 1 by 4 is the y value. So y value, this side I am concentrating. It should be greater than 1 by 4, and it can go up to 1 by 2, equal to 1 by 2, but should not be equal to 1 by 4, because at x equal to 0 the function is not defined. So you can see there is a discontinuity in the function when x is 0. Of course, the limit exists, but the function as it is not defined when x is equal to 0. But this kind of continuity is a removable continuity. There is a method to remove the continuity. You can redefine the function such that the circle is filled up. Okay. For example, you see here, this is the original function. The function x is not equal to 0, we can take that function, because the function is this function as it is not defined when x is equal to 0. Therefore, when x is not equal to 0, the function is root of x plus 4 minus 2 by x. But when x is equal to 0, you redefine the function to be 1 by 4. The redefinition is there to remove the discontinuity. Is it clear? So what will happen for when you take the function value when x is 0, it is 1 by 4. Now you see the discontinuity is removed. See once again, when I define the function to be 1 by 4, when x is 0, this is filled up and the discontinuity is removed. Understood it? Like and subscribe. Thank you. And thank you once again.